keeping the chatbot pretty deterministic while still allowing it to free jazz some things is kind of the trick there.
If you're trying to ask an LLM to do multiple things all at the same time, you're not going to get equal quality of all of the outputs or all of the suggestions. And that really can get out of hand at scale, it seems like, from what you've seen.
Latency goes down, accuracy goes up. In perception, it definitely is faster than a human is typing it out.
Hey, Aron. Well, welcome back, everyone, to another episode of Code and Cognition. And Aron, I'm excited to have you here because we're talking about deterministic chatbots. And I have a feeling we may get into some design pattern questions and maybe talking about some LLM as judge. And I want to hear your thoughts. I want to hear about your experience.
Pleasure. Love to.
Fantastic. Fantastic. And I think this is based off of a project you're currently working on.
Yeah, it's a project we have in the medical space where basically we have, without revealing too much of the customer, of course, right? They need to automate kind of like patient outreach. There's a specific script that they have to follow that varies over time, right? So they're like on certain this week I'm going to say this, the second week I'm going to say this, third week I say this, and so forth. And within each of those time periods, there is specific topics and ways they have to discuss. So it's kind of it is an opinionated workflow. It's not just like an open-ended chatbot.
Interesting. So there is a certain sequence or rules of engagement that this chatbot is supposed to be following.
Exactly. It's supposed to be following. It's like there are quite a lot of business rules and governing what it should say and how it should say it. So the timing of it and how it should respond to specific scenarios. That's quite a lot of basically emulating a human who does patient outreach. So, and what's there's a kind of like a happy path script it goes through, but it also exceptional cases can arise. The patient they're outreaching to wants to basically veer off topic or discuss some burning issue that is not part of their specific goal, right? So it's keeping the chatbot pretty deterministic while still allowing it to free jazz some things is kind of the trick there.
It does sound really tricky, at least from I'm interested to hear a little bit about how that journey has gone for like how do you do that? How do you make something specific, but then also give it enough like guardrails, but also give it enough freedom in certain cases? Because I know you can set expectations with system prompts. Yes, there's like more granular guardrails depending on the tech stack that you're using. And so I'm interested, what have you ended up with and where did you start?
Where I started was like it's a gigantic system prompt with like 5,000 lines that did not do anything for me. Basically, just could not you it could not keep the rules, the structure that's supposed to go through while maintaining the appropriate tone and all the very different scenarios. It just you just can't describe that all up front. The initial attempt basically produced a chatbot that would maybe 30% of the time do what I wanted to do, but like with not as far as like the sequencing of what it's supposed to do, like the hard business rules. If they ask this, you send this response, right? But the actual response itself would be like completely out of whack as far as its tone and the way it asks, and um or vice versa. It would be pretty poor about like getting to the right business rule response but actually respond pretty well. It cannot there's just not enough when you create god prompts like this it just doesn't work, right? So that's the initial that of course worked initially when we were just trying out small bits of it, but actually getting it to be like production reliable was the trick. So what we ended up with is basically a mixture of classical deterministic logic that acts upon kind of like LLM extracted facts from the unstructured data that is basically what a conversation is. So Basically, there's like a three-phased approach worked pretty well. And then there's of course many details about this, but basically, what worked is to have the LLM run one pass through the conversation and extract facts about it. Where are we, right? Where are we in the stream of the conversation? What have they said? What is their tone like? What is stuff like that LMs are good at inferring at, turning the instructor data into structured tags or structured information. Once you get that, feeding into a second phase, turning into like a determinist, like an engine, right? Basically takes all those facts and then converts it to, well, it looks like all these facts map to this type of scenario that we're trying to deal with. And based on the characteristics of the conversation so far, it looks like we want to have compose this type of response. Then we take that information and feed it to a third pass, which is the composer. That's the Shakespeare part of it. Given now, this second LM, third phase, this goes back to the LM and says, "We're here's the scenario where we're definitely at, and I need you to create. This is how you should make a response to it." So basically, a specialization on two ends using LLM with a deterministic engine in the middle. So,
You-
like that basic three-phase approach has had the best results so far. So,
Much more elaborate than just a 5,000 line system prompt.
yes,
Much
it's
more refined.
much more refined, much easy to test, right? There's a lot, the you can kind of test the deterministic engine part without the actual LLMs firing, right? You can test the composer part separately, and of course the analysis part also separately. So so it breaks the problem up into smaller chunks that have higher accuracy with more guardrails. And that's kind of like the gist of that. Does that make sense?
Definitely, definitely. And then I think so there's two questions that come to mind.
Mhm.
And I think you do a good job at explaining this first one, but I'll ask both of them and then we can handle them in order. One is, could you maybe explain a little bit more by what you mean for deterministic logic and how you're applying that into this workflow, especially for some of us who took logic in college from the professor who preferred to surf rather than teach. That would be helpful. And then number two is how I imagine there may be some issue with latency or latency with there between these three different steps because they build upon each other and you want to make sure you have the most accurate read of this is the like, this is what this person is saying or asking for. This is the context and the sentiment. And that needs to feed in accurately in order for your Shakespearean composer at the end to give the right response. So I'm interested to hear how answer to that as well.
Well, in our particular case, it's not meant to be necessarily real time conversation. The chatbot kind of sends messages. Um, uh, it's allowed to this based on their use case. It's allowed to not be exactly real time.
Excellent.
However, that being said, the by breaking up the problem into smaller pieces, we're allowed to create smaller prompts with much less context that can actually that could be if we need to compute more information like based on the initial analysis, right? Um, we based on it allows us to basically run smaller prompts, right, in parallel to get more information after that from the initial thing, and then basically use the context provided by the analysis of these smaller prompts and the initial analysis to like reduce the amount of prompt that we need to create in the Shakespeare side of it. Basically, we basically use the LM to hone down how much context we send going forward. So it's like, because if we're only discussing, I don't know, a topic A, why should we try have it? We should not send everything for topic C. We don't have to send A, B, and C. So that's where it's like latency and accuracy goes. Latency goes down, accuracy goes up. So I would say it's not like I mean it's not any it's definitely in perception, it definitely is faster than a human is typing it out. So if it was real time, right, it will actually some of our problems is that we need to make it look more human by not having it just stream out a bunch of messages right away, right?
Sure.
Yeah, so latency hasn't actually been a problem necessarily. But so I don't know if I'm explaining that a little bit. But
Definitely.
yeah, so basically, progressively honing down how much we have to rely, like the size of the queries matter, right? If you have gigantic 5,000 line prompt, it takes significantly longer, right? And I'll repeat myself a little bit. We can also parallelize the queries, right? So speed is not so important as much as cost, but even that goes down too, right? As we like pare it down. Okay,
Yeah.
does that answer kind of the second question?
Yeah, so you're able to utilize smaller prompts, which is costing less tokens, and you're getting a more accurate response.
Yeah,
And those smaller payloads also like
faster.
execute at a faster rate. And so you've really been able to increase quality, lower cost, lower latency, all at the same time with this architecture, which is pretty or design pattern particularly. So
Exactly. Yeah. So now let's talk about the deterministic second phase.
yes,
Yeah.
please.
So unstructured data turns into structured data, right? Say, well, indicating, for example, that the patient is angry and they haven't, and we can read the conversation that they're talking about, I don't know, physical therapy, let's say, right? So the given those two facts, that and also the third fact, which we know classically that it's this patient, right? And I'm not saying this is what this thing does, but it's an example.
Sure.
We can feed it into a function that basically says, hey, here's like 12 scenarios. Which scenario handler matches angry patient with physical therapy? Oh, physical therapy, angry patient, right? And so then all of a sudden we know we've targeted that um this is where we're targeted we're currently talking about physical therapy and the patient's angry. And given angry patient, right? We can use that information to say, well, if the patient is angry and they're currently on like some kind of medication that's supposed to be fixing your anger, then but they're obviously angry, so then we should probably uh that should result in the code which is, you know, have you taken your anger meds code. That have you taken the anger meds code and other contexts can give them to the Shakespeare composer, which can then use that fact to be like to talk to them about, hey, you know what? Have you taken your pills? Blah blah blah, and continue that way. So see what I'm saying? Basically,
Definitely.
you basically take the structured facts you got from unstructured data to find the handler of that topic to produce the metadata that will allow your downstream composer and other handlers, not just composer, right? To do something. You can do other effects based on that derived metadata, like logging, right? Like scheduling an appointment with a psychiatrist, right? And other things like that. So it's really um, one of the effects from this middle piece here is the composer piece, but really we'll use it for other things as well, like sending alerts or something like that.
Oh, I see. So there's some multiple functionality for this kind of last part of the brain or last part of the functionality. Another question that comes up in my mind is what else, if anything, is sort of feeding the response of the composer? Is it just this text conversation? Is there plans to have something also feeding it down the line? Like, I don't know, like best practice conversations when one is dealing with a patient that is experiencing crisis or is angry. I know there's lots of tricks of the trade in terms of that, or rules and regulations around that?
Well, actually, I'll start with even something a bit higher, right? Right now, we're basically using an untrained engine. It's like the bespoke, the bespoke the LLM. What actually we need to do to make the phrasing of the tone of and the tone of the various messages, the composer to sound more like the way they want it, is actually training a trained LLM. Right? So that's one of the inputs, right? This is basically take the corpus of I don't know, thousands of messages in production in the future and basically feed it into the training regime with metadata so that future messages relating to have you taken your medication are said in this tone. Because what you don't want to do is specify at a micro level in your prompt, the Shakespeare prompt, exactly how to do it, right? Because then you want to refine it in the future. But then other kinds of data, of course, that come in are classical structured data about about the patient. Like their demographics, their medical history, other things that can be used by the Shakespeare engine, right? Um, But as far as like other kinds of data, other than like other than facts about patients that come from the EMRs, the electronic records, that's probably with the extent of it.
No, that's great. Just wanting to know what else is feeding the context and or informing the nature of the conversation because there's so much data. How do you pick which one? And then in the world, in like the medical world, I think for me it comes, there's levels of regulation around what could be shared. The architecture has to be designed to support that in production. And then there is like on the clinical side, like what's actually working with a patient versus what's maybe like what's taught at the medical school of how one is supposed to be behaving in different specialties of certain areas of interest and expertise of how to work with patients. So wrangling all that into one LLM brain seems like quite the task.
Oh yeah, yeah, we're definitely. I'm just giving you an example.
Yes.
But we don't yeah, this thing doesn't actually use, like, their full medical history. We don't actually pull that in to inform stuff, but there are, like, certain facts about the patient or the subject that make its way, like, for example, we know their relatives, right? And actually be able to refer to their relatives by the proper pronouns and use those pronouns properly. Their phone numbers that are related to the various services connected to them are also worked into the conversation, right? And the names of support services also. So those are all pieces of context that we have to glue onto both sides of the LLM, both the analysis side and the composer side. And so, but you have to limit the amount of context you give because the more you context you give the LLMs, after a certain point, there's a tipping point where quality goes down. So we have to actually kind of decide when to show examples and when to show context because what we found is that it starts swaying the logic, right? Uh, More is definitely not always good, right?
Absolutely. I think a lot of us, if we've had experience either developing or even using it, it's a common experience and it hasn't been solved yet.
Yeah.
Oh, I kept on talking to it or telling it about something and really like it gets overloaded. It's swayed the perspective. It's really biased the individual instance of the conversation.
And sometimes if you give it like examples of what not to use too much or like in a way that is not exactly right, it starts using it, actually using it, like actually committing those same errors, depending on how much other context there is in the prompt. So you really, name of the game is to tighten the prompt as much as possible. Yeah.
And are you do you find that surprising? Or I
Yes.
suppose okay. Because considering that in the so in the design pattern to get the more accurate response, you are talking about like shorter prompts, shorter pieces of information, really more smaller discrete uh discrete inputs that have like less variability in their output potentially than something with 5,000 lines of complexity versus maybe 100 lines of complexity. So um, what is it? You know, I don't know how one builds an LLM, but I wonder if it's related to the size, if the smaller size has anything to do with it.
Well, you may have, for example, two things in a prompt, right? You have examples for dealing with this one, and you have examples for dealing with this one. Sometimes I have found the examples in this one interfering with the logic that's happening for this one. And if you're not careful about like contradictory examples, like it can get confused. So the more single purpose it is, the better. And 100% discovered that the hard way, right?
Sure.
Yeah.
So
So in other words, as much as possible, I have tried to not deal with two pieces of like, oh, if it's this, then do this. And if it's this, do this. If you can classically say you're only dealing with this, right? Because that makes a much better result.
excellent. So if someone was looking to make a chat bot similar to this or like this, would you want to recommend to them that they like really spend some good time up front, like either figuring out those examples and being able to use that to create the chatbot?
Definitely mapping out everything your chatbot can do, like all the branches. And then actually, this is actually a very important thing. Um, with a uh, workflow like this, um, without a proper regression framework that handles like all the use cases that the bot can go through, or like without that, it'll become very difficult to maintain and like expand your bot. So and to do that, why I mention that is that to have that corpus of regression tests, you have to think through all the cases, right? So um yes, so like basically the business rules of the bot decomposes to all of the use cases of the bot, and in each use case is test cases, right? That are the variations and all that. So having a test framework for and a way to build this so that you can run the bot through a regression suite, is critical. So yes, analysis and is very important. I think we spend like 5% of our budget so far, like just building 5-10% building tools to write and run regression tests relating to various different types of conversations, right? And the bot in its many permutations. You'll never capture everything, but you should spend some time like building a smoke test of all the normal happy path cases as the bot goes through the various different places. Yeah, but analysis is extremely important.
Excellent. What would you say, like, if you had a budget, like, throw out like a amount of hours someone should spend to like really plan that out? Um, what would you suggest? Because sometimes it can be so tempting just to like run in and try to create. You know, you can get a prototype working, or you can create a facsimile of maybe what the functionality could be, but then you realize at scale over certain users, oh, we're running into a problem, and maybe you haven't really thought through like, well, what could be the issue? But what I'm hearing from you, and when you have a system that's like this, it's a little bit easier to diagnose like, well, let's check this component of the system, let's check this component of the system, maybe it's the composer, and our data and inputs are actually good and being stored in the correct way, these are fine, but it's this last bit of the step.
Right. Exactly. So let's say like I model 5 different ways the conversation can go. Right? No, not crazy. Like 5 different way. When in fact there's like 10,000 ways the conversation can go, right? But it take 5 representative ways. Then I realized that, oh, so I can if I created a system that can run the bot through all 5 scenarios, right, with reasonable amount of time. In our case, we make the bot run all 5 conversations simultaneously. So the regression suite goes pretty quickly because right, so because the conversation is each conversation could take a long time, right? So now I realize that we want to tweak the way it handles the conversation in this way. If you didn't have a way to do didn't have a way to run all the other 4 conversations reasonably fast, you have to do them manually, right? But then it gets really crazy when you end up with like 200 scenarios. What are you gonna do in that case? Like you change these two, and how do you know what's going to happen to the way it talks in 198 other scenarios? That becomes really expensive in human terms pretty fast, right? So, um, so the investment, in my opinion, of an upfront way to create a library of conversations for your chatbot is very worth it, especially if you use the LLM to create that that framework for you in the first place, right?
Sure, exactly. No, thank you. That's really helpful to understand, how these design patterns are evolving or what you're seeing would be helpful because at the very least, it would be solving your problem that you're having like right now, or this is how you solved it. So
That's how I'm solving it, yeah, right now. Yeah, and if the tree of conversation is pretty wide, you really do need a way to make sure that when you optimize one thing, you don't bust all the other trees, right?
have you found that it's pretty easy to bust up the other trees when you're trying to fix one, or has it been easier or harder than you've expected?
What was interesting, right, is modifying the prompt and adding more and more rules into it to like clarify some aspect, right? And then I've sometimes I noticed that while I'm refining this part of the prompt, there's a degradation. There's the number of errors on completely like unrelated conversation paths increase. In other words, the adding more and more complexity to a one piece of the prompt that seemingly has no relationship to another one just has experimentally like reduced the amount of accuracy in conversations that rely on the other unrelated part. That was an eye opener for me, and one of the main reasons that caused me to really try to tighten down the prompt. Like this analyzer piece, I have gotten to a point where you do a first pass analysis that basically says it might be these two or three topics, right? And then run the secondary analysis prompt on those two, three topics to deep dive on those, right? Versus doing all the analysis all up front, all five topics. Because if you had a single prompt that had like 5 points of analysis, right? 5 characteristics it's trying to pull out, and you start beefing up this fifth one, for some reason the conversation paths that rely on the other four start having more errors more often.
Interesting.
And we're not talking about and it's not a gigantic prompt either. It's all within the context window, but it's experimentally shown, at least in my experience with this, it's it's surprising. It does get worse.
Sure. So it gets particularly worse. So again, very similar to this idea of if you're trying to ask an LLM to do multiple things all at the same time, you're not going to get equal quality of all of the outputs or all of the suggestions. And that really can get out of hand at scale, it seems like from what you've seen.
Yeah, and you really do want the tests to be able to help you tell that point because it's kind of hard. You can't fragment your prompt forever, right? I can't have like I can't call it like 25 times, like, for each little bit. You need to be a balance, right? Because each invocation costs time and money as well. So, so batching what the prompt does appropriately is the trick here. And I mean, I'm at least using my test suite to find that balance.
No, excellent. And in this, how are you utilize doing let me rewind to make sure I understand. And so with this prompt, so you'll query the LLM multiple times with the same prompt or certain chunks of the prompt in order to get that better result because you're giving it in smaller batches.
Yeah, yeah. I have like like that in the analysis step, it'd be like a prompt that tries to diagnose, like, does it look like problem A, B, C, D, E, F, but it's pretty shallow, right? And then the result of that first pass analysis will say, actually, it looks like there's two issues here. Oh, great, two issues. Now we have separate analyzer prompts that are focused specifically on those problems to like ask further information. And I get much more accuracy from that versus trying to embed that all in to the first one. And then I take the facts derived from the first prompt, and then there's these other two analyzer sub queries, right, to the LLM, and then use that in my classical engine, right, to go forward. That's the best. That's much. I've seen much higher accuracy there of using that technique.
Amazing. No, this is helpful. You really are breaking into discrete steps where
Exactly.
it's like, okay, we're starting fresh now based off of this output, brand new input that's relevant to this, uh, to your last output, and you're getting more accurate results in that way.
What's interesting is that works really well in analysis part, but like chaining the composer, I haven't figured out how to do that very well. Like basically come up with some answer and then you put it through another prompt to refine it, like fix its tone and do other stuff. I found that in that specific case, it doesn't work as well because the second prompt doesn't have us needs to have a lot of context to refine it. The same amount of context as the first one. So less of that on the composer part.
Sure. That's the next next nut to crack, so to speak.
Yeah.
This is like getting into the weeds a little bit in terms of the structure of how do you get a good result out. So this is quite nice.
Yeah, I think this approach is pretty general, right? In order to like and should be able to build many types of bots this way.
No, I think so. I think these design patterns very much can be applied to so many different use cases, like so broadly applied. Like if you want to be extracting information from a conversation and then using that as contextual inputs for whatever the purpose of the chatbot is. Um, and it's really easy to think of, the medical use cases, which is, like age, demographic, who they're living with in the house, that kind of information. It can create a really powerful personalized experience.
And I should say that this is like basically LLM as using LLM as judge, right? And then using LLM as composer. But the logic, logical bits, especially if it's quite wide, it's best to encapsulate that in classical logic, right? So yeah.
Okay, excellent. And then another design pattern I've heard you in when utilizing LLM as judge has to do with maybe using a more refined, aka maybe expensive LLM to be doing some higher level of logic or higher level of thinking. Is that something you're using, or have you been able to skirt around that maybe a little bit by really refining your inputs?
No, you have exactly hit on the thing. That second level analyzer, I use the expensive LLM, the latest one, right?
For sure.
Yeah, because that there you really when you're getting in there to really get the details and make like fine level analysis, right? I am currently using a different LLM than a different level, right? The more expensive one. This is partially in production already, the project I've done. It's a continuing evolving project. So yeah, maybe we'll talk about it in the future when we've achieved all our goals.
Very exciting. And then a good question for that has to be how have you heard about customer feedback? Like how what are people thinking? You alluded maybe a little bit of like, oh no, it's too fast. That's an uh interesting point.
Customer feedback. Well,
Or end user feedback, I suppose. Less of the customer, but end user.
the LLM doesn't handle exceptional cases very well yet, right? As in like when they start just talking about the president or like I don't know, just going really far afield or like they have problems that are not that we haven't anticipated, right? And because it can be anything, right? About anything. In those cases, we need to do a better job of like abort ship and make it and go back to manual. Um, you know what I mean? It's because the bot can't handle all the cases. So like that's actually an area that we're working on is to make sure that there's like a safety valve.
Sure.
Yeah.
For when the rails real we're not even on the same rails, we're on a different set of tracks entirely.
Right. Like having like when can we give up autopilot to the to human operators? So that's what that's that because that scenario can and does happen.
Sure, so there needs to be a handoff between the LLM and an actual human.
Yes.
Wow.
Yeah. So it's a I would say that this kind of project is very complicated to do. It's one of the it's like an exciting and invigorating type of engineering problem, you know? Uh so yeah, we'll see how it goes.
Well, it sounds like, what is it? Progress is being made, obstacles being overcome. No one can ever predict the timing of any outcome in these kind of novel ways. So, forward, fantastic. I think it seems to be. It's been exciting. It has been exciting to hear how it's been going so far.
Very cool. My pleasure.
Fantastic. And yes, I can't wait for this to go forward a bit more and then see how this is developed.
Yeah. Awesome.